So this is the video for the Counting by Mass lab. And the purpose of this lab is to use mass to determine how many particles are in a sample of material. So we're going to compare mass to the number of particles, whether that be atoms or molecules, in a substance. So for this lab, we are going to be testing a series of different components, and we're going to see what their mass is. We are also going to use mass to count how many beads are in the container. So for part one, we are going to try and figure out how many beads are in this container. So the first thing I need you to do is I need you, in your hypothesis, to predict how many beads are in this container. So that's part one of your hypothesis, is to predict how many beads are in this container. Now, for part two of this lab, that's when we're going to be massing the different substances. So if I were to give you a mole of aluminum, iron, copper, sulfur, zinc, and magnesium, what do you think their masses would be? So that should be your hypothesis for part two. So if I were to give you a mole of aluminum, iron, copper, sulfur, zinc, and magnesium, what do you think the mass will be? Okay, so let's jump in and do the procedure. So we're going to do part one first. Part one, step one, says using the bead, the empty container, and a mass balance, determine how many beads are in the container. Record your number in the data table. So I have a couple of different things here. I have my whole container of beads. I have an empty container, and I have a single bead. So I'm going to start by massing my whole container with my beads. So if I put that on the balance, the mass of the whole container with the beads is 106.03 grams. So it's 106.03 grams. Now, if I find the mass of just the container, I can figure out the mass of just the beads. So the container itself is 24.25 grams. So the container itself is 22.25 grams. Take that off. And then the mass of one bead is 0.26 grams. So the mass of one bead is 0.26 grams. So if I know the mass of my whole container of beads, the mass of my empty container, and the mass of one bead, I can figure out how many beads are in this container, and that's what you need to do for part two. Okay, for part one, sorry, that was part one. Moving on to part two, so I have several bags of substances, and I'm going to mass each one. Now on each bag is written the mass of the empty bag. So what you need to do is, your job is to figure out the mass of the stuff inside the bag. So the mass of this bag holding zinc is 4.4 grams. The mass of the bag with the zinc is 70.51 grams. So that's 70.51 grams. Okay, substance two. So this is sucrose, and the mass of this bag is 4.4 grams. So the mass of the bag and the sucrose is 192.33 grams. 192.33 grams. So remember, you're supposed to be trying to find the mass of just what's in the bag. So I just gave you the mass of the sucrose plus the bag, and the mass of the bag is 4.4 grams, so you should be able to figure out just the mass of the sucrose. Okay, so this is calcium chloride. Mass of this bag is 4.4 grams. And the mass of the calcium chloride with the bag is 140.86 grams. So 140.86 grams. Moving on to aluminum. Mass of this bag is 4.4 grams. Mass of the aluminum plus the bag is 31.31 grams. Then we have sodium chloride. The mass of sodium chloride, or the mass of the bag, is 4.4 grams. Mass of the bag with the sodium chloride is 62.87 grams. So 62.87 grams. And then we have sulfur. The mass of this bag is 4.4 grams. Mass of the bag with the sulfur is 36.42 grams. In this bag we have iron. Mass of the bag is 4.4 grams. Mass of the bag with the iron is 60.42 grams. In this bag we have copper. Mass of the bag is 4.4 grams. Mass of the bag with the copper is 68.05 or 0.6 grams. And then last one is magnesium. Mass of the bag is 4.4 grams. Mass of the magnesium with the bag is 28. Well, let's see. Let's try this again. .55 grams. Okay, now for each of those you need to compare the mass of just the substance to the mass on the periodic table. So the mass on the periodic table, you're going to look in the box and you're going to look at the bottom number, so the number that's a decimal. And that's the mass that you're going to compare it to. And you're going to compare only the ones that are elements. So you're going to be comparing aluminum, iron, copper, sulfur, zinc, and magnesium to their mass numbers on the periodic table. Once you do that, you may find, hopefully, that the numbers are very, very close to the masses on the periodic table. That's because those are the accepted results. So 1 mole of a substance is going to have the mass that's on the periodic table. That's because your numbers should match, because I gave you 1 mole of the substance. We specifically measured out 1 mole of each of these elements. So this is what a mole of copper looks like. And remember, a mole is 6.02 times 10 to the 23rd particles. So this is what 6.02 times 10 to the 23rd carbon atoms looks like. So each of these bags contain 1 mole of the substance. So if it was an element, you'll find that the mass that you calculated from lab should be similar, very, very close, to the mass that's on the periodic table. That's because that mass on the periodic table is equal to the mass of 1 mole of that substance.